Hello, here we are at Unit 3 about angles and triangles, and this focus is on learning target 1 and 2, where we can identify congruent angles formed by parallel lines that are cut by a transversal and justify the relationships that exist. And then you'll be able to find measures of angles formed when those parallel lines are cut by a transversal. Here we go. So in geometry, a line that intersects two or more lines at different points is called a transversal. You write that word in on your notes or write it down on your notebook if you didn't copy your notes. And then we're going to label the transversal in a diagram and the parallel lines L and M. So AB is the transversal, the parallel lines L and M. They make 8 different angles. You can see them at the different points of intersection. And we're going to look at the names of those angles and their relationships. They are the 2 lines divide the planes into 3 regions that help us name these angles. So there's the exteriors, they're above and below the parallel lines, and the interior. And I did ask you to label those because it relates to the naming of the angles. All right, so again, the interior, yellow, the exterior, the 2 regions that are not between, but outside. Okay, when a transversal line intersects 2 lines, 8 angles are formed, and the angles are given special names. So we'll review those. There's alternate angles, and they are on opposite sides of the transversal, same side angles on the same side of the transversal. Interior angles lie between, so they're inside and then your interior area. Exterior angles are on the outside of the 2 lines. So we look at alternate interior angles. We're going to focus on those in a moment to show how they're related to one another in size. Alternate exterior angles. So like 1 and 7 would be an alternate exterior angle, so would 2 and 8. Same side interior angles, that would be 4 and 5 on the same side but inside that area. And then same side exterior angles, they would be like 1 and 8 and 2 and 7. So let's take a closer look at the angles here written in red. Again, we have a transversal in the middle and a bunch of angles are formed. And so the first ones we talked about were alternate interior angles. So 4 and 6 are an example of those, and you can write those in your notes. They are on opposite sides of the transversal and they are between the lines, so they're the interior part. Same side transversals would be an example of 3 and 6. So write those down. They're on the same side of the transversal, but they're interior, right? In the interior region. And then we have an example of alternate exterior angles, 1 and 7. Go ahead and write those down. They're on opposite sides of the transversals. And so you see them outside the lines. Finally, in this section, we're looking at same side exterior angles and on the same side of the transversal. We talk about those. So 1 and 8 would be an example of that, as would 2 and 7 on the same side. All right, moving on. We're going to kind of look at the relationships they have in terms of degrees. So if 2 parallel lines, again, are cut by a transversal, then the alternate interior angles they are congruent. So in your box on your notes, you'll write down the first angle name is alternate interior. There's a picture of that with 3 and 5. 4 and 6 would also be that. And they are congruent, meaning they are equal. So if you know the angle measure of 3, you know the angle measure of 5. If you know the angle measure of 4, you know the angle measure of 6. Another kind that we just talked about are same side interior. So you write that down in your box there. And they, same side interior, are supplementary, meaning they add to 180. So 4 and 5 are an example of supplementary angles. Whatever, if you knew 4, you could figure out 5. If you knew 3, you could figure out 6, vice versa. So supplementary, same side interior. Another supplementary example is same side exterior. So that would be like 1 and 8, they equal to 180, supplementary. 2 and 7 equal to 180, they're supplementary. There are a couple other angle relationships we're going to talk about. After this, alternate exterior is our final set that is within this parameter that we've just been talking about. And they are congruent, angle 1 and 7, angle 2 and 8. So alternate exterior congruent. So just to review all those again, because you're writing them down, we have alternate interior, and they are congruent in those examples. Same side interior, they are supplementary. Here's those examples. We have same side exterior, they're supplementary. Here's the examples, 1 and 8, 2 and 7. Supplementary meaning 180. And then alternate exterior, they are congruent. And that would be 2 and 8, 1 and 7. So if you know one, you know the other. Okay, a couple other ones are corresponding angles. So they are on the same side of the transversal, and they're the same shape, and they are congruent. And I was going to have you draw an example of that. So you can use 1 line, 4 lines, 3 lines, 2 lines to represent which angles are congruent in those relationships of corresponding angles. Stop the video if you need a little more time. But continuing on, vertical angles are opposite angles formed by intersecting lines. So you're going to fill those words in, and that happens whether you have parallel lines or not. And so an example of those opposite angles would be 1 and 2, 4 and 3, 7 and 8, 5 and 8. So they are the same measures. If you know one, you know the other. Give yourself an example, stop the video if you need to, but just draw down an example of vertical angles. They are always congruent. Okay, and finally, adjacent supplementary angles, supplementary being that they add up to 180. Talked about some of those relationships with same side interior and same side exterior. Well, same thing happens if the angles are along the same line. So 1 and 2 are supplementary, 6 and 5 are supplementary. They add up to 180, so you can find one if you know the other, and you know they're on a line. So we're going to do a little practice with these, trying to figure out the measure of different angles and justifying them. So in order to do that, we'll just review the types of angles pairs formed when a transversal cuts those two parallel lines. We have alternate interior angles are congruent. Alternate exterior angles are congruent. Corresponding angles are congruent. Vertical angles are congruent. So that means they all equal the same. The kind that add up to 180 are the same side interior angles, same side exterior angles, and the linear pair that are along a line. So keep those justifications in mind. Come back to this slide if you need to. And here's where we're going to do our practice. Name some angles that are congruent to angle 1. Give a reason for each. You can stop the video and practice, but when you start it up, here are some of my justifications. 3 is congruent to 1 because it's corresponding along the line there. 6 and 1 are congruent because they are vertical relationship. 8 and 1 are alternate exterior angles along that transversal. 9 and 1 are congruent because they are corresponding. 14 and 1 are congruent because they are alternate exterior angles. So there's two transversals on this kind of parallelogram here. And so we have two alternate exterior angle relationships. And then finally, kind of more challenging is one that's further away. And so for two reasons, one is congruent to 16 because it corresponds to 3, and 3 is an alternate exterior with 16. So that means if it's congruent with 3 and 1 is congruent with 3, then 1 is congruent with 16. All right, last challenge. Let's practice actual degree measurements. So find all the remaining angle measures. So when you know 1 in your paper, you're going to write down what you think 2 is, and then you're going to justify that. When you know 3, you're going to write it down and then justify it. 4, 5, 6, 7, 8, and give your justifications. So on here, when you are done, you can stop and start the video. But remember, you're going to need your justifications for why these are the way they are. And we'll probably have different reasons that you use. So a lot of answers can exist for that. And that's what I have for you for parallel lines and transversals. And good luck. We'll move on to our practice after this. Thanks.